Alright, this is a video for IOD 201, Parallel 1. This is question 2. Hopefully you've had a chance to attempt question 2 at this point. You should not be watching this video unless you are really unsure about it or have already attempted it. IOD stands for Interpretation of Data. And 201 is select a single piece of data, numerical or non-numerical, from a simple data presentation. For example, a table or graph with 2 or 3 variables or food web diagram. Okay. We've already scanned the passage because we've already done question 1. So we're going to look at question 2. According to experiment 1, what was the corrected absorbance of the solution with the 4.0 ppm concentration of SO3-2? Okay. So what's important? Well, the fact that we're looking at experiment 1 is very important. We're looking at 4.0 ppm concentration of SO3-2. That's also very important. And we need to find the corrected absorbance. Also important. Okay, so we're going to go up to experiment 1, and we're going to look for 4.0 ppm concentration of SO3-2. And then we're going to look for the corrected absorbance. Alright, so 4.0 ppm in experiment 1. Here's experiment 1. Here's the data. 4.0 ppm is here. If we move straight across, we see it hits the line at this point. We go straight down. Corrected absorbance, which is what we're looking for, is 0.6. So let's do that again. The concentration is what we know. It's 4.0. We're going to move straight across till it hits the line right here at this point. And then we're going to move straight down to find the corrected absorbance, and it is 0.6. So we go back to our thing here. 0.6 is the correct result. Okay. Good. And I forgot to do this in the past one, but we're going to circle it this time, because that's what we're supposed to do. Always follow the directions, right? Good. Okay, so 0.6 is the correct response. Why? Because the graph shows that when SO3-2 is at a concentration of 4.0, its corrected absorbance is 0.6. Okay? Oh, let's add, because the graph in experiment 1, that's important information, right? Okay, so now, why are these incorrect? Well, let's look for 0.2. Let's go, gosh, this is just a pain to get this to show up inside of the circle, huh? Well, we'll ignore it. 0.2. If we go up here to 0.2, okay, here. Well, if we were to go straight up from 0.2, this response, we would see that, I don't know, the concentration of SO3-2 is going to be like a little less than 2. There's no point on this showing us that, but we use the line. So we go straight up from the 0.2 corrected absorbance, and we go straight across, and we see it be a little bit less than 2. So maybe like 1.8 or something. The corrected absorbance of SO3-2 when at 0.2, wait, is 0.2 when its concentration is about 1.8 ppm. Now I use ppm, right, because that's what concentration's in, ppm. Now I said about here, and this is really right here. This is really important. Okay, why did I say about? Any ideas? Why didn't I say exactly 1.8 ppm? Okay, this is something that's part of the way information is displayed in a graph. It's not as detailed sometimes as you get in a table. Or another way to think about it is the graph actually connects points you know, and all the things in between the points you know are kind of points you're guessing at because you don't have actual data there, but you're assuming that those points are there. And when I draw these, sort of lines up here, and I can actually make some lines so we can actually have a sort of exact measurements, or as exact as we can get to here, and then to here. You can see that like I can get close. I can kind of figure out to a little bit of some degree of certainty what the answer is, but not for sure, right? Maybe that's, now that I draw the lines, and maybe not even 1.8, maybe that's more like 1.6. Okay, it's hard to tell exactly what the number is going to be. So that's why I said about, because I don't know for sure. I know it's close to that. I know it's about 1 point, and I should change that to 6 now that we've actually done the lines. But it's probably close. Okay, I'm assuming the rest of these are going to be similar. So, but it's not 1.6. This is 0.3, right? Because the new response is 0.3. This is not 1.6 anymore. We got to go measure it again. So let's look at 1.3. I'm going to draw the lines this time because, that's always good. Oh, and this one lines up to a point, so that makes it easier to do. Okay, so this one's going to be like 2.1. So we'll go 2.1. And again, it's about 2.1, right? 2.1 ppm. So this one's incorrect because if we measure the corrected absorbance, is if it's 0.3, then the concentration that we see up here, 0.3, concentration is just over 2. Alright, and the last one, okay, instead of 0.2, this one is 0.8. You can see here, 0.8. And we go up to the graph. Do the same thing again for 0.8 is here. I'm going to draw my line up and try to make it as straight as I can. And then I'm going to draw another one directly across. Best I can. That's pretty straight. Okay, and this one ends up being what, like 5.6 maybe? 5.6, we'll go with that. Alright, so we go down here and change this to 5.6. So, incorrect, incorrect, incorrect. Again, remember, this is the correct response because on the graph at 4.0, which is what they're asking for in the question, at 4.0 ppm, the corrected absorbance is 0.6. Actually, we should add ppm in here so that we are sure. The absorbance is 0.6, right? Because we back up here, 4.0, we can do our lines just so we're sure. But at 4.0 is what the question asks. Okay. It's 0.6. Alright. Okay, so I hope this was informative. I hope at this point you should be ready to go and take the third assessment and hopefully demonstrate mastery and move on to the next one.